Good day. I'm going to discuss about linear regression. So first, what is regression? Regression analysis is a statistical process for estimating the relationships among variables. It helps in understanding how the typical value of the dependent variable changes when any one of the independent variables is varied while the other independent variables are held fixed. So for linear regression, given the formula y is equal to a, which represents the y-intercept, plus bx, wherein b represents the slope, given this data in our table. So first, we need to find b. So b, which is equal to n, which is the total number of the x, times the summation of x, y, minus the summation of x, times the summation of y, all over n, the summation of x squared, minus the summation of x quantity squared. Going back to our table, we can already obtain the data, which for x times y, we have the summation of 14.16, and for the summation of x, we have 22.50, and for the summation of y, which is 8.82, and for the summation of x squared, which is 64.77. So, changing the variables in our data for the equation of b, we're going to have 10 times 14.16 minus 22.5 times 8.82 all over 10 times 64.71 minus 22.5 squared. That will give us the value of b, which is negative 0.40. So now we already have the value of b, and we can now find the value of a, which is the y-intercept for our formula. So a is equal to the summation of y all over n minus b times the summation of x all over n. Going back to our data for our values, we're going to have 8.82 all over 10 minus 22.5 all over 10 times negative 0.40, and that will give us 1.79. Having the formula for linear regression, which is y is equal to a plus bx, we can already change our formula with the given values. So the linear regression, or the required formula, is y is equal to 1.79 minus 0.4 x.
After solving for the linear regression, we now proceed to other non-linear relationship. The first one is the exponential model. We have to use this formula. Y is equal to e raised to a times e raised to bx. By using this formula, we need to find the value of b, which is equal to n times summation of x capital Y, which is ln y, minus summation of x summation of capital Y over n times summation of x squared minus quantity summation of x squared. By using this formula, we need to substitute the values, which is n, the total number of the data, summation of x times capital Y, which is negative 14.68 minus summation of x 22.50, summation of y negative 3.12 over 10 quantity summation of x squared, which is 64.74 minus quantity summation of x 22.50 squared is equal to negative 0.54. After solving for the value of b, we need to solve for the value of a, which is capital Y over n minus b times x over n. With this formula, we can get negative 3.12 over 10 minus 22.50 over 10 times negative 0.54. And we can solve for the value of a, which is 0.902. After getting the both values a and b, we need to substitute the values in the formula. Y is equal to e raised to capital A times e raised to bx. And by substituting, we could solve for, the answer is y is equal to 2.47 e raised to negative 0.54x.
Now we have solved the problem using the exponential and the linear equation. Now we will use the logarithmic power equation to solve the problem. To start the problem, you will change the values of x into logarithmic function of x. So these are the values and get the total. And for the y, change the values of y to logarithmic value function of y, and these are the values. So negative 1.36. And for the x squared, simply square the values on logarithmic x and do it one by one. So this will give you 1.52. Same thing as from y squared. And to get the xy, simply multiply the log x and log y one by one and get the summation. For the b, use that equation, and b is equals to n summation of xy minus summation of x times summation of y all over n times summation of x squared, this one, minus summation of x squared, this one. And by inputting the values, you will get negative 0.966. And for getting the value of a, y all over n minus bx all over n. For the y, you will use this value. So, and for the x, you will use this value. For inputting by inputting the given values, you will get 0.132. And for the y, for the exact equation of the problem, since it is in a logarithmic power equation, y is equals to 10 raised to a times x raised to b. So, input the values to this equation, and you will get this one, and you will get y equals 1.355x, 0.996.
Hi friends, so today I'm going to teach you about the saturation growth rate, or what do you call hyperbolic function. So here the x and y element. The big X is converted into the inverse of x. So this is, and the y also. So this is it. Then the formula of b is equal to n summation of xy minus n summation of x times summation of y over n summation of x squared minus minus summation of x quantity squared. So if you substitute all of the variables there, you can get the value of b. And if you get the value of y, use the formula. So the value of big B is equal to the... So you can get the value of B by dividing the computed value of big B over the computed value of big A. So the result is negative 0.56. And the value of A is equal to the 1 over computed value of big A. So the result is 0.374. So if you get the value of B and A, you can substitute it for the original formula. So the y is equal to 0.374x divided by x minus 0.56. So that's the saturation growth rate or hyperbolic function.
After solving the equations for the linear, exponential, power, and saturation growth rate, it is time to know which is the best fit model in solving the problems. By doing this, we can use Pearson product moment correlation coefficient. What is this? This shows the relationship between the x elements and the y elements of the given data. The equation of Pearson product moment is n times the summation of xy minus summation of x times summation of y all over square root of n times summation of x squared minus summation of x element squared times n times y squared minus summation of all y elements squared. We can do this in our linear by substituting the all given summation to the formula. Here we can see that we already plug in the given datas where 10 times 14.16 minus 22.5 times 8.82 all over square root of 10 times 64.77 minus 22.5 squared times 10 times 10.33 minus 8.82 squared gives us the value of negative 0.95. This negative shows us that the x elements and the y elements are inversely proportional. After solving for the Pearson product moment of the linear, we are now going to solve the exponential. Here, we can see that we change the values of the y into the big Y, which is the ln of all y elements. We are now going to plug the values into our formula. 10 times negative 14.68 minus 22.5 times negative 3.12 all over square root of 10 times 64.77 minus 22.5 squared times 10 times 5.12 minus negative 3.12 squared. Here, we will get the value of negative 1.00. Again, the negative value shows that they are inversely proportional. Now, we are going to solve the Pearson product moment of the power equation. We are going to change the small x into big X, which means the logarithm of all the x element. And we're going to change the small y into big Y, which means the logarithmic value of all y elements. So our equation now will be n times summation of big X times big Y minus summation of big X times big Y all over square root of n times summation of big X squared minus summation of all x element squared times n times big Y squared minus summation of all y elements squared. Plugging the values that are necessary for the equation, we can get the 10 times negative 1.1 minus 2 times 78 times negative 1.36 all over 10 times 1.52 minus 2.78 squared times 10 times 0.97 minus negative 1.36 squared. We can get negative 0.95. Again, it shows that the x element and the y element are inversely proportional. After computing for the simple
Wait,
power...
sige, ulitin mo. 1, 2, 3, go.
After computing for the Pearson product moment of the simple power equation, we are now going to solve for the saturation growth rate Pearson product moment. Of course, we are going to change the small x into big X, which is the reciprocal of all the x element, and the big Y into the reciprocal of all the y elements. This is the equation where n is times the summation of x, y minus summation of x times summation of y all over some square root of n times x squared minus times the summation of all x element squared times n times the y squared minus summation of all the y elements squared. Plugging the necessary values, we are going to get 10 times 7.35 minus 6.56 times 16.95 all over the square root of 10 times 6.82 minus 6.56 squared times 10 times 42.73 minus 16.95 squared. We are going to get the negative 0.63, which indicates that x and the y elements are inversely proportional. Upon getting all the Pearson product moment, we can now determine the best fit model to use in solving problems. We can see that all of the Pearson products are negative. However, the best fit model is the exponential, because if you get the absolute value of the exponential, we are going to get the 1, which is the closest value to the absolute value of 1. Spearman-Rank correlation is a non-parametric measure of association between the x element and the y element. Given is the English mark as the x element and the math mark as the y element. We can get the rank as x and y by using the 10 as the lowest and 1 as the highest. D is the difference between the rank x and y elements. D squared is the square of the difference of the x and y elements. This is the equation for the Spearman-Rank correlation, where 1 minus 6 summation of d squared all over n times n squared minus 1 will give us the answer. Substituting the necessary values of d squared, we can get the Spearman-Rank correlation of 0.67, where 1 minus 6 times 54.5 all over 10 times 10 squared minus 1 will give us the necessary value of Spearman-Rank correlation of 0.67. Since it is positive, it shows us the x element and the y element are directly proportional.